In this video, we'll talk about intersections and unions. So intersections first. The intersection is when both A and B occur at the same time. So notice that and. So we'll write it as probability of A and B. Notice this upside down little U shape. That's our symbol for intersection. So probability of A and B is a probability that A and B will occur. If I was to draw a Venn diagram for the intersection, if this is A and this is B, then the intersection will be this part where they overlap. Let's try some examples. Let's say we want to draw one card from a standard 52 card deck. Let's find the probability that it is red and a jack. So by logic, there are 52 cards in a deck. They're all going to be equally likely to be drawn. I have here a diagram of all the cards in the deck. So you're either red or black. Red can be hearts or diamonds. And you have the numbers 2 to 10, jack, queen, king, and ace. So we want it to be red and a jack. So red, here's our red, and jack. So it looks like there are only 2 red jacks. So 2 red jacks out of 52 cards means then that our probability of being red and a jack is going to be 2 out of 52. Let's try our next one. What's the probability of drawing a card from a standard 52 card deck and having it be black and a number? So black and a number, looks like these are all black and numbers. So there are 18 black number cards out of 52, which means then that the probability of getting black and a number is going to be 18 out of 52. Now you can write it with this intersection or you can write it with an and. You'll kind of see me go back and forth because I want you to kind of remember or get used to seeing it both ways. So that's an intersection. Now let's talk about unions. The union of A and B is the events consisting of the sample space outcomes belonging to A or B or both. So this means if I was to draw it, here's A, here's B. If you want the union, notice this is now a right side of U. The union would be everything in A or everything in B or kind of what's here on the inside. So just as long as it's in one or both, it counts. Now you might wonder what would happen if we had a situation like this. So here's A, here's B. Then the union would be anything in A or B or both. It doesn't have a both, so it's just whatever's in A or whatever's in B. So we have a general addition rule. If we have 2 events, and the 2 events are A and B, the probability that A or B or both, so A or B or both will occur, is going to be the probability of A plus the probability of B minus the probability of A and B. Now, why do we do this? You might have thought about this as I was shading up above. So if I was to do this formula, so probability of A union B is equal to the probability of A. So let's shade A. So we shaded A. Plus the probability of B. So come back and shade the probability of B. Now notice what happened to the things in the middle. What happened here? That was counted twice. The area in the intersection was counted twice. So what we're going to do is we'll minus the probability of A and B. Okay, so again, the area in the intersection was counted twice. So we'll subtract it out once and then we should be correct. Now if you have again, two disjoint events. So I know we already talked about disjoint events. You'll find that we often kind of talk about things multiple times. But two events, A and B, are disjoint if they have no sample space outcomes in common, so they can't simultaneously occur. In this case, the probability of the intersection would be 0. So here's A, here's B. They don't overlap at all, so there's no intersection. So that means the probability of A and B would have to be 0. Now the reason we talked about this again, or reminded ourselves, is because we also have an addition rule for two disjoint events. Because if we have if A and B are disjoint events, then the probability that A or B will occur is just going to be probability of A plus probability of B. Why don't we have to subtract the intersection? Well, if you think of the general rule, the probability of A or B is equal to probability of A plus probability of B minus probability of A and B. But this has to be 0 because there's no intersection. They don't overlap at all. Well, if you know that this intersection, the probability will be 0, why bother writing minus 0? So it simplifies to this rule because we know there won't be an intersection, so we don't bother subtracting the intersection. So let's practice. Suppose that 40% of adults get enough sleep and 46% exercise regularly, but only 24% of adults do both. What's the probability that an adult gets enough sleep or exercises regularly? I always go through any problems and write down what they give me. So probability of sleep equals 40%. Probability of exercise equals 46%. But there's probably some people that both exercise and get enough sleep. And indeed, it told me 24% of adults do both. So probability of sleep and exercise, I'll abbreviate it, is 24%. Now that I wrote that down, what's the probability that an adult gets enough sleep or exercises regularly? So probability of enough sleep or exercise is going to be the probability of enough sleep plus the probability of enough exercise minus the probability of enough sleep and enough exercise, because you don't want to count in that intersection twice. So this would be 40% plus 46% minus 24%, which gives me 62%. So there's a 62% chance that a person is getting enough sleep or exercising regularly. So are the events get enough sleep and exercise regularly disjoint events? Give me a numerical reason. So on this one, disjoint means you can't possibly be in both groups at the same time. But we know that's not true because there were 24% of people that both get enough sleep and exercise. So I would say this is not disjoint because 24% of people do both. Or if you wanted to think about it this way, you could say, well, if they were disjoint, then the probability of getting enough sleep and exercising would be 0. But we found the probability of getting enough sleep and exercising was 24%. So since it's not 0, this means not disjoint. Our next one, according to the M&M website, the color distribution of M&Ms is blue is 24%, green 16%, orange 20%, etc. here. We want to know, are the events blue and orange disjoint? Why? So I would say you can't be blue and orange at the same time. You can't be two colors at once. So I would say they would be disjoint because you can't be two colors at the same time. So now let's find the probability of blue or orange. So the probability of blue or orange is going to be the probability of blue plus the probability of orange. And then you should think minus the probability of the intersection. But wait, we don't need the probability of the intersection because they don't overlap at all. So we can just stop there. So probability of blue is 24%. Probability of orange is 20%. So we're at 44%. Okay, now pause it. Try this next one yourself. And for our last example, let's find the probability that a reader subscribes to the Atlantic Journal or the Beacon News. This is different than what we've been doing. This is what we call a contingency table. Okay, and it's just a different way to display our data. So you'll notice in here, a person can either read the Beacon News or not read the Beacon News. And they can either subscribe to the Atlantic Journal or not subscribe to the Atlantic Journal. Now, there are people that read the Beacon News and Atlantic Journal. That would be this cell right here. There are people that read Beacon News and don't read the Atlantic Journal. That would be this cell here, etc. So it's just displayed in a table formula. So let's see if we can do this one. So we're looking for the probability of Atlantic Journal or Beacon News. So probability of Atlantic Journal or Beacon News. Well, this would be the probability of Atlantic Journal plus probability of Beacon News. But you don't want to count the intersection twice, so let's subtract out the probability of the intersection. So probability of Atlantic Journal and Beacon News. Okay. So probability of Atlantic Journal. To get probability of Atlantic Journal, you have to look at everything in this first row. So everything in the first row would be 650,000 out of our grand total of 1,000,000. Now for Beacon News, you'll need everything in the Beacon News column. So that's 500,000 out of a 1,000,000. But we counted this cell right here twice. This one was counted twice. So let's subtract it back out. So the probability of the intersection was 250,000 out of 1,000,000. And if you put all this into your calculator, you should get 0.9. So we have a 0.9% chance that they subscribe to the Atlantic Journal or the Beacon News.